Picture this. A former tech executive takes one of the most notoriously unsolvable math problems in history, builds a structural proof for it, and then uses that exact same proof to pitch a mathematical model of divine grace to the Pope.
I mean, it sounds like a totally surreal work of fiction, but that exact sequence of events is actually the reality of this newly released Omega Genesis Protocol manuscript.
Exactly. So welcome to today's deep dive for March 12th, 2026. Our mission today is to unpack this manuscript, which proposes a groundbreaking structural resolution to the Collatz conjecture.
Yeah, the classic 3n+1 problem.
Yeah, if you're listening, you probably already know the headache here. You take a number, have the evens, multiply the odds by 3, and add 1, and you just watch it bounce around chaotically.
Until it inevitably, inexplicably crashes into that endless 1-4-2-1 hailstone loop. Mathematicians have basically been pulling their hair out over those hailstones since 1937.
Wow, almost 100 years.
Yeah, and the historical stumbling block was always trying to measure the sequence's raw size. Tracking the sheer magnitude of those chaotic ascents is, well, it's mathematically impossible to bound universally.
Right, because to solve an impossible problem, you have to completely change how you measure the chaos. So the protocol ditches those raw numbers for a metric called post-odd valuation depth.
Which is such a fascinating shift in perspective.
It really is. Think of it like mapping a massive, uncharted mountain range. Instead of trying to measure the absolute peak elevation of every single mountain, which could just go on forever, you measure the total angle of the downward slopes.
Just to prove that eventually every single path drops back to sea level.
Exactly. It's like judging a roller coaster by the structural momentum of its drops, not the absolute highest peak.
I love that analogy. And that structural momentum is really the engine of what the author calls the structural reduction program. They use a compressed transition operator, defined as U of n.
Okay, so what does U of n actually do in practice?
Well, rather than viewing every single math step in isolation, U of n groups an expansion, like the multiply by 3 and add 1 part, together with all of its immediate divisions by 2.
Oh, I see. So you aren't getting distracted by the erratic spikes, you're just tracking the net descent.
Precisely. And by tracking that net descent, U of n forces all those seemingly random mathematical trajectories into one of 4 distinct residual families, S, R, H, and C.
They basically act as 4 behavioral buckets.
Right, and then the burden of proof completely shifts. You no longer have to track infinite numbers, you just have to prove these 4 specific structural families always collapse.
And they verified this empirically, didn't they?
They did, using a 3072 modulus. It's an incredibly dense computational stress test that filters through astronomical number spaces to hunt for edge cases.
And the number of surviving candidates was...
Exactly 0. 0 survivors found even under that extreme pressure.
Okay, wait. I'm stuck on a transition here. The author of this protocol, Timothy J. Dillon, is a former tech leader, right?
Yeah, he managed massive platforms for Microsoft, Expedia, and Nike.
Right. So he's taking this theoretical math and applying it to enterprise technology. But, how does a math proof actually govern real-world AI or cybersecurity?
It feels like a massive leap, doesn't it?
Totally. I mean, software isn't just a string of dividing by 2.
It isn't, but it works through translation. So Dillon built a platform called the CVP Spin Overlay. It takes this math concept of structural reduction and turns it into a structural intelligence engine for software.
Okay, so how does that stabilize a system?
Well, in a complex IT system, you inevitably get recursive loops and chaotic memory leaks, essentially digital hailstones. The platform isolates those unstable zones in real time.
And then it uses the math's underlying logic to just deterministically force the software back to a stable state?
Exactly. It forces convergence.
Wow. So if you can map the chaos of abstract numbers, you can mathematically force order onto a crashing IT system.
Which brings us right back to that wild executive presentation to Pope Leo XIV.
Yes. Dillon proposes that this exact same architecture governs human morality.
It's pretty wild. He maps out what he calls syntropy, representing order or grace, against dispersion, which represents entropy or sin.
Treating theology as a literal algorithmic subsystem.
Yeah, modeling Christian virtues as mathematical forces. He defines M2, or forgiveness, as a state where present entropy must strictly exceed past dispersion.
Just to neutralize historical deficits, think of it like a digital ledger.
Right. If sin is algorithmic entropy, like a historical deficit in the system, you can't just ignore it. You have to actively inject a mathematically greater volume of order, or grace, to zero out the ledger.
He even maps M7 peace as the mathematical limit of sustained order and minimized dispersion.
This is a totally different paradigm.
It really challenges you to look at the world differently, because whether you are dealing with recursive AI loops, abstract math, or your daily moral choices, everything might be governed by the exact same structural architecture of order versus chaos.
Right, as Dylan beautifully points out, this protocol doesn't close the book on Collatz, but it changes the shape of the book.
Yeah, by making the infinite auditable.
It fundamentally shifts our perspective on complexity, moving away from sheer magnitude to focus purely on underlying structure.
Exactly. Which leaves you with a profound thought to chew on today. If virtues like forgiveness and humility can be modeled as literal mathematical forces pulling a system toward a theoretical omega point, could our daily moral choices actually be altering the physical structural topology of the universe around us?